Alright, this is going to be the lecture on Chapter 14, Introduction to Networking. I know you all have to take a networking class, a lot of you in Cisco, so this is just going to be a high-level overview on networking because you will go more in-depth when you take the networking course, and definitely more in-depth if you do in Cisco. The objectives of the chapter is how different networks are wired, or the wireless networks, how to identify common network cables, how Ethernet works, about the OSI and TCP IP models and different protocols, how to identify a MAC, IPv4, and IPv6 addresses, to set up a wired and wireless network, about common network troubleshooting tools, to configure and access a network printer, how to configure apps on a mobile device, and how to be a proactive technician is your soft skill. And then your comp TIA objectives, being able to differentiate between motherboard components, their purposes and properties, compare and contrast various connection interfaces and explain their purpose, identify types of network cables and connectors, categorize characteristics of connectors and cabling, be able to explain properties and characteristics of TCP/IP, explain common TCP and UDP ports, protocols, and their purpose, compare and contrast wireless networking standards and encryption types, install, configure, and deploy a SOHO wireless wired router using appropriate settings, compare and contrast internet connection types and features. Given a scenario, use appropriate networking tools, install and configure laptop hardware and components, compare and contrast the components within the display of a laptop, compare and contrast laptop features. Given a scenario, install and configure printers. Given a scenario, use appropriate safety procedures. Given a scenario, install and configure the operating system using the most appropriate method. Given a scenario, use appropriate command line tools. Given a scenario, use appropriate operating system features and tools. Given a scenario, use control panel utilities. Set up and configure Windows networking on a client or desktop. Explain the differences among basic OS security settings. Explain the basics of client-side virtualization. Establish basic network connectivity and configure email. Execute and configure mobile device synchronization, and given a scenario, troubleshoot wired and wireless networks with appropriate tools. Alright. A network, as it relates to computers, is two or more devices that have the ability to communicate with one another and share resources. A network allows computer users to share files, communicate with, via email, browse the internet, share a printer, modem, or scanner, and access applications and files. Networks can be divided into four major categories based on the size of the network. They are PAN, LAN, MAN, and WAN. A PAN is your personal area network. Personal devices such as PDAs, cell phones, laptop computers, and pocket video games that can communicate in close proximity through a wired network or wirelessly. Playing a game between two laptop computers wirelessly is an example of a PAN. A LAN is your local area network, a group of devices that can share resources in a single area such as a room, home, or building. The most common type of LAN is Ethernet. A LAN can be wired or wireless, and the computers in a networked classroom is an example of a LAN. A MAN is a metropolitan area network, a connectivity between sites within the same city. A MAN connects multiple LANs. MANs can be wireless or use fiber optic cable. Multiple college campuses connected together is an example of a MAN. A WAN is a wide area network, communication between LANs on a larger geographic scale. The internet is an example of a WAN, just as two networks located in two cities is a WAN. And then you have the WLAN, which is the wireless LAN. It's a wireless network that consists of an access point and some wireless devices, including laptops, netbooks, ultrabooks, tablets, and smartphones. A wireless network can be short range, such as when Bluetooth is used, or a wider coverage, such as a wireless network for a home or business. Wireless bridges might be used connect devices between two buildings. An WWAN is a wireless WAN, wireless connectivity for a larger geographic area using a mix of technologies, cellular or WiMAX. Okay, there are two basic types of LANs, a server-based network and a peer-to-peer network. With a server-based network, computer users log in to a main computer called a server where they are authenticated. The server is a more powerful computer than a normal workstation. The server contains information about who is allowed to connect to the network and to what network resources, such as files, printers, and applications. The network user is allowed access. So when you log in, it will give you your rights as they are set up on the computer. Another name for a server-based network is client-server network. Windows computers is a server-based network, or commonly called a domain, or a Microsoft Active Directory domain. One or more dedicated servers log and track users and resources. Domains are commonly found in business environments. A peer-to-peer network does not have a centralized server. Instead, each computer is its own server and resources are shared between the workstation computers. The computer user sets up passwords to allow others access to the resources on or directly connected to that computer. A person uses the network to access remote files, printers, applications, and so forth with his or her own workstation. Server-based networks are more common in businesses, whereas peer-to-peer are more common in homes and very small businesses. A server-based network can consist of 10 or more computers. In contrast, a peer-to-peer has fewer than 9. It's usually in the range of 2 to 9. Windows computers in a peer-to-peer network are known as a work group or a home group. 2 or more computers configured with the same workgroup name can share devices such as printers as well as files and folders. A server-based network is more secure than peer-to-peer. This is because the server is normally in a locked network room or wiring closet. Servers have a special operating system loaded on them called an OS, or a network operating system, such as Microsoft Windows Server 2008 or 2012, Red Hat Enterprise Linux, and Sun Solaris. A network operating system has utilities that allow computer user management, resource management, and security management. Since peer-to-peer networks do not use a dedicated server, costs are reduced. Instead of a network operating system, each workstation uses an operating system such as Windows XP, Vista, or 7. A peer-to-peer network is not as secure as a server-based network because each computer must be configured with individual user IDs and passwords. The physical network topology is how the network is wired. The figure here on the slide shows topologies for networking. Keep in mind that a large business may have combinations of these topologies, and a topology that combines multiple topologies is known as a hybrid topology. Ethernet networks are the most common type of LAN. Each network device connects to a central device, normally a hub or a switch. Both the hub and the switch contain 2 or more RJ45 network jacks. The hub is not as intelligent as the switch. The switch takes a look at each data frame as it comes through the switch, and the hub is not able to do this. The different topologies there, you have the star, which consists of a central node, hub, switch, or computer, to which all other devices are connected. If one device fails, this does not include the hub, but if one of the computers that's hooked to the hub or the switch fails, all other devices continue to function. All information passes through the central device before being sent to the destination device. Your extended star connects multiple star topologies together by connecting their hubs and switches to a central switch. Your hierarchical devices connect to a switch or hub on the level above it. It's sometimes called the tree topology. A large number of devices can be connected this way. Your ring has a center ring of cable to which all hosts connect. Each device is directly connected to 2 others. Single direction data flow, and a failure of a device affects all other devices. Your bus is single line to which all devices connect, and a failure affects all devices. And then your mesh is reliable due to built-in redundancy. Each host is connected to every other host, so if one path is bad, another should be available. Your bus is not your most common anymore. Takes less cable and it's cheaper, but if there's a break in the bus, the network's down. Your mesh with a break in the cable, the network still works. It's fault tolerant, but it takes a lot of cable. It's expensive and complex, so it's not as common for to be in use. Ring, each network device connects to two adjacent network devices. It's easy to install but requires expensive parts. And then your star is the easiest to install and is your most commonly used, and a break in the workstation cable does not affect the rest of the network. Networks require some type of medium to transmit data. This medium is normally some type of cable or air. The most common type of cable are twisted pair copper and fiber optic, although some very old networks use coax cable and video networks use coax. Air is used in wireless networking where data is sent over radio frequencies. The most common type of copper media used with computer networking is UTP, or unshielded twisted pair. Most people are familiar with twisted pair cables because this type of cable is used in homes for telephone wiring. Twisted pair cable actually comes in two types, shielded and unshielded. The acronyms used with these are SDP for the shielded and UTP for unshielded. SDP cable has extra full shielding that provides more shielding. Shielded twisted pair cables used in industrial settings such as factories where extra shielding is needed to prevent outside interference from interfering with the data on the cable. Twisted pair cable used with networking has 8 copper wires. The wires are grouped in colored pairs. Each pair is twisted together to prevent crosstalk. Crosstalk occurs when a signal on one wire interferes with a signal on an adjacent wire. UTP cable is measured in gauges. The most common size of UTP are 22, 23, 24, or 26 gauge. UTP cables come in different specifications called categories. The most common categories are 5E and 6. You'll hear these called Cat 5, Cat 6, Cat 5E. Your different ones, you have 3, and it's mainly installed for telephone systems and office buildings. You have 5, which is no longer a recognized standard. It was replaced by 5E. 5E is known as Cat 5 Enhanced. And then you have 6, which supports gigabit Ethernet, and it's better than 5E, but uses larger gauge, thicker cable. And then you have 6A, which supports 10 gig base T Ethernet and frequencies up to 500 megahertz. There's a chart there on page 735 in your book that goes over these. Alright. To connect a computer to a switch or network wall outlet, a straight-through cable is used. This is also known as a patch cable. When connecting two computers together, a crossover cable is used. And I think it shows that. Here you go. It shows here straight through and crossover. Alright. New technicians commonly mistake an RJ11 phone jack or connector with an RJ45 network jack or connector. An RJ11 connector has 4 conductor wires, and an RJ45 connector has 8 conductors. Another type of copper cable is your coax. Coax is used in star and bus topologies and is most popularly found in video networks such as those that connect TVs in schools. Most people have seen coax cable in their homes. The cable used for cable TV is coax, but it's a different type than the cable used with network cabling. Coax cable has a center copper conductor surrounded by an insulation. Outside the insulation is a shield of copper braid, a metallic foil, or both, that protects the center conductor from EMI. And that was your categories there. Alright, fiber optic is made of glass or a type of plastic fiber and is used to carry light pulses. Fiber optic cable can be used to connect a workstation to another device, but in industry the most common use of fiber optic cable is to connect networks together, forming the network backbone. Copper cable is used to connect workstations together. Then fiber cable is used to interconnect the networks, especially when the network is located on multiple floors or in multiple buildings. The two major classifications of fiber are single mode and multi-mode. Single mode fiber cable has only one light beam sent down the cable, and multi-mode allows multiple light signals to be sent along the same cable. Single mode cable is classified by the size of the fiber core and the cladding. Common sizes include 8 1/25 and 10 1/25 microns. The first number represents the size of the core. The second number is the size of the cladding. Single mode cable allows for distances over 50 miles at speeds over 100 gigabits per second. And then multi-mode cable, on the other hand, can support distances over 1 mile and speeds up to 10 gigabits per second. Your cabling tools, you have a toner probe, and a tone generator is connected to a cable or inserted into a network jack, and the tone generator injects a tone down the cable. The toner probe is touched to the other end of the cable to identify it. The tone generator toner probe combination is used to identify cables when they are not labeled or are labeled incorrectly. You have a wire stripper, which is used in creating straight through UTP patch cables or crossover cables. You have a punch down tool, which is used to connect network cables to patch panel or phone cables to punch down block. Network cable testers used to check coax and UTP cabling. A crimper is used to permanently attach an RJ45 or RJ11 connector to a cable. Ethernet is your most common type of LAN, and more time must be spent on understanding it because technicians constantly add and remove devices from an Ethernet network. Some issues related to Ethernet include full duplex and half duplex transmissions, network slowdowns, and increasing bandwidth. Ethernet networks were originally designed for half duplex, which is both directions, but only one direction at a time, transmissions, on a 10 megabits per second bus topology. Today's Ethernet networks support speeds of 10 megabits, 100 megabits, 1,000, and 10,000 megabits per second. Most Ethernet NICs are 10, 100, 1,000, which means they can run at either 10, 100, or 1,000 megabits using full duplex, transmit and receive simultaneously. And then here the charts in your book that goes along with this slide. There that does out your Ethernet type, which is 10 base 10, and gives you a description of the speed and the cabling. You can look over the slide or the chart in your book on 741 on your own. If you have any questions, let me know. And then your IEEE, Institute for Electrical and Electronic Engineers, committees create network standards called the 802 standards. Each standard is given an 802.x number and represents an area of networking. Such as 802.5 is your token ring access method. These again are in a chart in your book on page 742 and 743. Take a little bit of time and look over those standards, your standard numbers, and what they apply to. If you have questions on that, let me know. Alright, your OSI model. The International Organization for Standardization has developed a model for network communications known as OSI, or Open Systems Interconnect Model. The OSI model is a standard for information transfer across the network. The model sets several guidelines, including how the different transmission media are arranged and interconnected, how network devices that use different language communicate with one another, how a network device goes about contacting another network device, how and when data gets transmitted across the network, how data is sent to the correct device, and how it is known if the network data was received properly. All these tasks must be handled by a set of rules, and the OSI model provides a structure in which these rules fit. The OSI model divides networking into different layers so it's easier to understand. Dividing the network into distinct layers also helps manufacturers. If a particular manufacturer wants to make a network device that works on layer 3, the manufacturer only has to be concerned with layer 3. This division helps networking technologies emerge faster. The layers of the OSI model from the top down are application, presentation, session, transport, network, data link, and physical. Each layer of the OSI model uses the layer below it, except for the physical layer, of course. Each layer provides some function to the layer above it. For example, the data link layer cannot be accessed without first going through the physical layer. If communication needs to be performed at layer 3, which is the network layer, then the physical and data link layers must be used first. Each layer of the OSI model from the top down, except the physical layer, adds information to the data being sent across the network. Sometimes this information is called a header. And there in your image, it shows how a header is added as the packet travels down the OSI model. When the receiving computer receives the data, each layer removes the header information. Information at the physical layer is normally called bits. When referring to information at the data link layer, use the term frame. When referring to information at the network layer, use the term packet. Each of the 7 OSI model layers performs a unique function and interacts with the layers surrounding it. The bottom 3 layers handle the physical delivery of the data across the network. The top 4 layers handles the ins and outs of providing accurate data delivery between computers and their individual processes, especially in a multitasking operating system environment. And then the chart there on 745 in your book, when you start with the physical layer, it defines how bits are transferred and received, defines the network media connectors and voltage levels. Data at this level is called bits. Then your data link encapsulates bits into frames, can provide error control. MAC address is at this layer, and switches reside at data link layer. Then your network layer provides path selection between 2 networks. Routers reside at the network layer and send data toward the destination network. Encapsulated data at this layer is called a packet. Your transport provides the mechanisms for how data is sent, such as reliability and error correction. Your session manages the communication and synchronization between network devices. Presentation translates data from one character set to another. And then application provides network services, file, print, and messaging services to any software application running on the network. Alright, and then your TCP/IP is your transmission control protocol, internet protocol model. It's a network protocol, is a data communication language. A protocol suite is a group of protocols that are designed to work together. TCP/IP is the protocol suite used in networks. It is the most common network protocol and is required when accessing the internet. Most companies use TCP/IP as their standard protocol. Homes do as well. And the TCP/IP protocol suite consists of many protocols, including TCP, which is your transmission control protocol, IP, which is your internet protocol, DHCP, which is your dynamic host configuration protocol, FTP, which is your file transfer protocol, and HTTP, which is your hypertext transfer protocol, to name a few. The TCP/IP model describes how information flows to the computer when TCP/IP based protocols are being used. The TCP/IP model has only 4 layers. You have your from the bottom up, you have your network access, which is called your link layer. In the original request for comment, defines how to format the data for the type of network being used. Alright, so for example, if Ethernet is being used, an Ethernet header including unique source and destination MAC addresses will be added here. A MAC address is a unique 48-bit hex number burned into a chip on your NIC, and the network access layer would define the type of connector used and put the data onto the network, whether it is to be voltage levels for ones and zeros on the copper cable or pulses of light for fiber. And then you have your internet, sometimes called the internetwork layer. IP is the most common internet layer protocol. IP as a source and destination IP address to uniquely identify the source and destination network devices. An IP address is a unique 32 or 128-bit number assigned to a NIC. Your transport layer protocols add port numbers in the header so the computer can identify which application is sending the data. When data returns, this port number allows the computer to determine into which window on the screen to place the data. Protocols include TCP and UDP. And then you have your application. TCP/IP based application layer protocols format data specific for the purpose. It's equivalent to the application presentation and session layers of the OSI model. Protocols include HTTP, Telnet, DNS, HTTPS, FTP, TFTP, TLS, SSL, POP, SNMP, IMAP, NNTP, and SMTP. And then you have a chart in your book on 746 that shows the devices operating at the OSI and TCP/IP model layers. So your router, your wireless router, and your router on your OSI layer is at your network level. Your TCP/IP is the internet level or layer. Your switch, wireless access point, and wireless bridge. In the OSI model, that's your data link, and in TCP/IP, it's your network access. And then your hub, wireless antenna, cable, and connectors. At your OSI level, that's your physical, and at your TCP/IP, it's your network access. Alright, to keep the videos from being so very long for this chapter, I'm going to stop here and then pick up in another video.